Okay, so now let's look at an example dealing with a confidence interval for a mean. Okay, so here we have a large company concerned that many of its employees are in poor physical condition and is leading to decreased productivity. The company provides a pedometer to 50 randomly selected employees to use for one 24-hour period to estimate how many steps each employee takes per day on average. The company's statistician reports a 95% confidence interval of 4,547 steps to 8,473 steps. So let's interpret the confidence level, and note that interpreting the confidence level is different than interpreting the interval, right? So if I want to interpret the confidence level, what does it mean to have a 95% confidence level? And what that means is that if we take many samples and calculate the confidence interval for each, then about 95% of the intervals will capture the true mean number of steps by employees. Right? So we're saying if we use this method that we're going to be discussing in this chapter for calculating confidence intervals, and we do it many, many times for many, many samples, right? We have a sample mean and a different sample mean and a different sample mean. And for each of those sample means, we calculate a confidence interval to try to capture the true population mean. Then about 95% of the intervals will capture that true mean. Now, very important to understand that that's different from interpreting the confidence interval. For interpreting the confidence interval, what we would say is we are whatever the confidence level is, in this case 95%. So we are 95% confident that the interval, we provide the interval, captures the true mean number of steps taken by employees. And this is going to be the format for interpreting the interval, and this is going to be in the format for interpreting the level. All right, for the level, we talk about making intervals, and for the interval, we talk about confidence. Okay, and always, always, always include what the confidence level is, what the interval is, and what you are representing. Is it a proportion? Is it a mean? Is it something else? And the context, in this case, the mean number of steps taken by employees. Okay, now let's determine the point estimate and the margin of error used to create the interval. Well, the point estimate is nothing more than the center of the interval, so I take the average, add the two numbers, divide by 2. That's 6510. That's X bar. That's my point estimate. It is the sample mean because I'm trying to estimate about the population mean. The margin of error, well, it's the distance from the center to the endpoint. So 8473 minus 6510, 1963 is the margin of error. All right. So once again, how you might see this also written is to say, hey, 6510 plus or minus 1963. So the other way that you could talk about the interval, all right, so it's going to be, hey, about 6,500 plus or minus about 2,000. So it gives you a general idea as to the values. So from about 4,500 to about 8,500, and we see those values. Now, recent guidelines suggest that working age people aim for 10,000 steps per day. Is there convincing evidence that the employees of this company are not meeting the guideline on average? Well, how would we answer that? What we could answer is to say, yes, the evidence is convincing at the alpha equals 0.05 significance level. Right? Now, 0.05 for alpha is because 95% is the confidence. So 0.95, the complement to that, 0.05. And because all the plausible values of the interval, right, all the plausible values for the true mean are in the interval, and they're all less than 10,000, our evidence is convincing at the 5% level of significance. always look to include context. Always look to include your support in your responses. All right? If my value is in the interval, it's plausible, it's not convincing. If my value is not in the interval, then we would say it's convincing at the particular level that we decided upon to build the interval. Now, the last question for this part. Is it possible to determine the percentage of employees that get between 45, 47, and 84, 73 steps? The answer to that is not without more information. All we know right now is the sample mean, 6510, and the sample size, 50. That's all we know right now. We would need to know the sample standard deviation as well. And if we knew the sample standard deviation, along with the sample mean, the sample size, and then later we'll discuss this idea of degrees of freedom, which is nothing more than the sample size minus 1 when I'm only working with one variable. If I had all that information, then I would be able to estimate. But without that information, without knowing that standard deviation for the sample or a good estimate of the standard deviation for the population, without that information, I cannot determine how many employees actually got between 45, 47, and 84, 73. It is not 95%, right? 95% refers to our approach to building the interval based on a particular sample. It does not represent the probability of having my employees within that interval, okay? So be sure that you understand that distinction. To determine the percentage of employees that get between the values in the interval, you need to know the standard deviation. And really what you would be doing is calculating the normal probability from a sampling distribution. But this right now is not a sampling distribution. It is a confidence interval. Okay? Thank you very much for your time.